and thank you for joining us today as we talk about simplifying and scaling cron jobs with temporal schedules. The schedules feature recently went into general availability, and it's a durable and scalable replacement for traditional cron systems. My name is Irina Belova, and I'm a product marketing manager here at Temporal. Now, let's jump into even more exciting things. I'm thrilled to introduce today's speakers, Julia Wang from Watershed, our amazing Temporal user, and David Race from Temporal engineering team. And with that, I will hand it over to you, David.
Thanks, Irina. Okay, so schedules at Temporal. So I'm David. I'm an engineer at Temporal. I did most of the design and implementation of the schedules feature. So I'm probably the best person to talk about it and answer questions. So I'm going to give an overview of what we were trying to do with it, what's the problem we're solving, how we improved on other systems, and a bit of a demo or overview of how to use the feature and some of the different things you can do with it, and then talk a little bit about some of the internal engineering details that might be interesting to some of you, and then there'll be time for questions at the end, as Irina said. So, what problem are we solving? Okay, so it's a super common thing in lots of applications to want to do something on a schedule, to do a recurring job, some kind of batch job, or generating reports, or syncing data from somewhere, or polling something. So very common problem. How do you do this? Well, there's hundreds, maybe thousands of pieces of software that can run things on a recurring schedule. I'm going to pick just a few other solutions to compare how they differ from our solution. So there's the old standard Unix cron, I guess first one that should be mentioned. If you work with cron, you might know that it's not a good fit for modern applications running in the cloud. But why is that? What are the specific features or misfeatures? Cron runs on a single machine. It's in a single. It runs a single process on a single machine, and if anything happens to that machine, then the job won't run, or it might, it might crash in the middle. This is sort of falls under the category of reliability. Another problem is usability. It's kind of hard to use. The syntax is confusing. It's one I admit I've been using cron for 20 years, and I still have to look up the order of fields in a cron tab file. One point that used to bother me, it's hard to test cron jobs. You put something in the file, and then you don't know exactly how it's going to run. The environment might be different when it actually is run by cron, and there's a lot of missing features that you might miss. Control over overlapping runs and skipping runs, and observability. So this is also very important. You can get logs from cron, maybe if you've set up some kind of log syncing system. Maybe it'll send email if you've set that up correctly. But basically, you don't get a lot of visibility into what it's doing at any time. So single machine-based solutions are not very good for cloud applications. So we're looking for a distributed solution. Well, Kubernetes cron. Kubernetes has a cron feature. This is okay. I've used it a little bit. We actually have a few of these running in one of our automated testing systems. So it sort of works. Still, it's not quite the high-level abstraction that we're looking for. So when I run, so first of all, consider the same issues. So for reliability, it works better in that you can set something up with a configuration. It'll run in a distributed way. It'll try to run your job even in the face of single machine failures, but it might run them more than once. there's some caveats with how Kubernetes cron schedules things. Usability, well, you're still specifying a job as a container image and then maybe a command, a shell command to run, which is not the highest level, not the kind of high level abstraction that I want. And of course, it's still using that same confusing cron tab syntax. Observability story is better, navigating around your job runs and things and getting logs, at least if you use some front end like K9s or something. But so what do we want? Like, what's the ideal thing that we want from a cron type system? We want it to be reliable. We want it to run your job exactly once, exactly when it's supposed to. We want it to be easy to understand what to read a specification, understand exactly what it's going to do, without looking up any weird syntax. We want lots of features so that we can have control over what we're running without adding mutual exclusion things to the actual job that we're running. So we want to we want to avoid having to put a lot of extra logic in the job we're running. And we want some kind of nice UI that lets us poke around and see what happened in the past, what's going to happen in the future. Logs from looking at logs and output from all these things from the jobs that we run. And then also I'll add another one. We want it to be very scalable, so you can run thousands, tens of thousands, hundreds of thousands of jobs. Okay, so what did we do to solve all these problems? Temporal is a great foundation for building, well, any sort of application, but specifically for this purpose, Temporal, so reliability is one of our sort of core company values, and reliability is a thing that Temporal does very well. Workflows are the foundation of reliability. You start a workflow and it will run to completion. It will continue running in the face of failures. So we looked at workflows, and we like to say everything is a workflow. That applies to schedules and schedule jobs too. In fact, in the current implementation, a schedule is just a workflow. That's sort of an internal detail. You don't need to worry about that. But that is how it's implemented at the moment. Schedule jobs are workflows too. So if you've already incorporated Temporal into your application, that sounds like exactly what you want to do. That's the obvious thing. If you haven't incorporated Temporal into your application, you might be worried like, oh, I have to rewrite lots of things in Temporal. Well, you can, but you can also, it's also very easy to wrap any code that you have in an activity in a workflow. And then you get the full power of temporal workflows. You can choose timeouts, you can choose retry policies, you can choose between at least once and at most once semantics for your activities. And basing things on workflows, we get great scalability as well. Temporal is designed for millions of concurrent workflows, so supporting millions of schedules is easy. There are a few caveats around scaling, but basically it makes it very easy. So what's the next thing we did? We made a schedule specific API, so that when you're interacting with schedules in temporal system, you're interacting with schedules with a dedicated API that's not the workflow API. So you can manipulate schedules as schedule entities. The API offers tons of there was an old temporal cron feature. Some of you may have used that. The difference with what we did with schedules is that with old temporal cron, a schedule is a property of a workflow. And now we've made schedules an independent entity. The API is mostly resource based, so it's familiar, it's easy to use. You create schedules with a specification where you can include a configuration that includes tons of features, and there's a sort of CRUD style API for manipulating them. And then finally, we made a web UI to make it easy to see what's happening in the system with all your schedules. Okay, so let me go through some examples and show you what things look like and how some of the features work. So I'm gonna demonstrate things using the command line interface first, and then also screenshots from the web UI. And then all these things are available programmatically in code as well. So basically creating a schedule, this is using the temporal CLI. Almost all the features are available in the CLI, and most of them in the web UI as well. So let me note a few things about this. So a schedule has an ID, in this case, my schedule. That ID is a unique ID for a schedule in your namespace, and that's going to be, you can use that, it's going to show up in the UI, of course. You can then use that to manipulate your schedule, take actions on it, update it, delete it, all those things. Note that in this case, we, for how often to, or like when to run the job, we're using a very simple constant interval of 2 days. That's, I mean, personally, I find that a lot easier to read than the cron style syntax. We do, of course, we support cron style syntax as well. We support cron style syntax, and then also an easier to read form of that, which I'll show later. We can express exactly how much jitter we can tolerate for starting jobs. If you've used systems like this with large numbers of jobs, you might know that if you have 1,000 jobs all starting on the hour every hour, that's not a great idea. It can overload downstream systems and other things like that, cause other problems like that. So we built in jitter, and jitter is expressed separately from the when to run thing. So separately from the interval or calendar spec or anything like that. We have overlap policies. So these are different ways to control what happens when jobs are going to overlap. I'll explain more details on that in a little bit. And then the rest of the options here for temporal schedule to create are just the same options that you would get if you were starting a workflow from the CLI, and the same applies in the UI also. So after we create the schedule, what do we do? Oh, sorry. This is the web UI version of that. There's fields for basically all those same things that were in the CLI. So after we create the schedule, what do we do? Well, we can look at it. There's a list command that shows you the schedules that exist in your namespace, and a little bit of metadata about them. And on the web UI, of course, you see something very similar. There's those recent runs, by the way, are links to the corresponding workflows that it ran at that time. The recent run in this case isn't exactly lined up because I ran it with a trigger, which I'll show in a minute. You can describe an individual schedule, and you can get more detail that way. You get the pause states available in both. This is a sort of overview. I'm showing the card view because it's easier to fit on a slide. This is a sort of overview of what's happening overview of the metadata about the schedule. If you want more information, there's more available using raw, and then you get this whole JSON thing. This is very similar to what you get if you did it programmatically in code. For example, for each of the recent jobs that it ran, you'll get the time that it ran, the workflow ID and run ID for all those, so you can go from there and look them up. And in the web UI, here's what you'll get for a single schedule detail view. And again, these are links to the corresponding workflows. Let's see. So suppose we want to test our job. So we created a schedule for it, but we want to know what will happen when the schedule kicks off that job. We can do a trigger, and this will run the job in exactly the same way that it would have been scheduled if the schedule ran it. You may wonder how this interacts with if the schedule is running, has a run that's going on concurrently. It will, the overlap policy for the schedule will take effect. So if it was skip, then it would skip the run, which isn't very useful. So it's common that you would override the overlap policy when you trigger a run immediately. We can do the same thing on the web. This is just the sort of box that pops up and gives you a choice of overlap policy when you do that. So maybe we create a schedule that's going to run a job. The job depends on some other system, and we found a bug in that other system. So we want to stop scheduling, stop running that job temporarily. So we can do that. So there's this pause feature. We can do that with the CLI like this. We can note that we can give a reason. The reason will appear in the notes field here. So anyone else who's interacting with the system and looking at things can see that's what's going on. It's a way to pass a little bit of information. You might use that to link to an internal issue tracking system or something like that. And in the web UI, you can do the same thing. When you do pause, the schedule won't run any jobs, but other features, including trigger immediately, are available. During that time when you paused, maybe suppose we fixed the bug in the other system. The jobs that it skipped over when it was paused didn't run, but maybe you want them to run now that you fix things. You can do a backfill where you can specify a time range, also an overlap policy, and it will run the jobs that would have been run during that time if it wasn't paused. You can do this even if it wasn't paused. It'll just rerun them again. You can do it in the past or the future. It's just it just does what it would have done in that time period. All of these features are available in all of our language SDKs as well. So here's some Go code that does the basically create the equivalent schedule to what I showed with the CLI. Manipulating things programmatically means you can create schedules that are more like cattle than pets. You might have a schedule for each user in your system. You might, or some other business entity. So they don't think of them as things that always have to be managed manually by hand. So let me quickly run through a few of the features that can help you make schedules and jobs that do exactly what you want and no more. So we have these overlap policies. 6 options. They do pretty much what they sound. You can buffer a run so that they'll run sequentially. If one of them takes long enough so that the next one would run, it'll buffer them all and run them sequentially. You can also have them cancel or terminate the previous one, and you can have them run in parallel. So that's all your choice. There's a let's see. So I only showed a sort of constant interval. You can also use cron expressions for compatibility. You can use a nicer JSON form of that. This is how it would look on the command line. And then this is how it would look in Go. Other languages are probably even a little bit less verbose than that. There's some more options for scheduling things. Here, so you can exclude certain times. You can constrain the start and end times of a schedule to run just, for example, like you could say every day for the next 15 days, but then stop, no more after that. Of course, you can use time zones. Catch-up window is you can sort of prevent jobs from running too late in case the temporal system was down during that time. Pause on failure if, for example, if you have a backup job or something and it fails, you might not want it to run again until someone comes and takes a look at what went wrong. And you can include an action count. So you could say something like run every hour for the next 10 hours, but no more. And then when jobs run sequentially, you can each job can look at the result of the previous run. So you can sort of pass information from one to another and make sure that you don't skip anything in a series of actions. Okay, so I have some content of talking about how things are implemented behind the scenes. Let me go through a couple points then. So how do we implement all this? I'll say first that it was actually pretty easy to implement. Maybe that makes me look bad. But it was because I could rely on all the powerful primitives that Temporal provides. I said earlier, schedules are literally workflows, at least right now. We're planning to change that in the future to make things even more reliable. But for now, the easiest way to implement things in the way we did it at first was literally mapping API operations to workflow operations. So here's kind of how it works behind the scenes. When you create a schedule, that turns into a start workflow on this internal schedule workflow that we've implemented. So create schedule is going to start the schedule workflow running, and the schedule workflow is going to do what it does. When you delete schedule, it just terminates the workflow. It's all like kind of surprisingly straightforward. Describing the schedule and getting that data out of it turns into a query in Temporal. Update and patch, which is used for trigger immediately in backfill, turns into a signal to the workflow. And then list schedules turns into list workflow executions. There's a little bit of work that we have to do, to sort of translate these operations. But if you look at the implementation, it's actually fairly straightforward. So what exactly is what does the workflow do? So I mentioned there's this internal workflow. In theory, it's very simple, right? You figure out when you want to do the next thing. You sleep until that time. Workflows can sleep for any amount of time, and that'll work reliably. Then you start the job, and then you loop and figure out the next time. Well, it started out that simple, but there's a lot of complications and things to pay attention to and how that's working. There are the signals, as I mentioned. This is an infinite loop, so we have to use continuous new appropriately. Side effects to keep it deterministic. There's a buffer. There's it has to cancel and terminate things. Sometimes it has to wait when you're buffering. You have to wait for the previous run to complete before you start the next one. Deal with paused, lots of other stuff. Okay. Let me let's see. There's maybe there's one more little implementation detail that I wanted to mention, because this is a trick that you might use in your own applications on Temporal. So I'll just do the first one, and then we can leave the rest for afterwards, maybe. List. So I said that. Let's see. List schedules is just list workflow executions. But I also said that when you list schedules with the CLI or web UI, or in code, you get some metadata with each schedule. When the last run was, for example, when the next run is scheduled. List workflow executions just gives you, if we didn't do anything else, you would just basically get a list of IDs and then not much extra information. So how did we, well, unless you queried each one, right? You could get a list of schedules, you could query each one to get some more detail. That wouldn't be very efficient because it's essentially an n+1 query, right? You get the list of things and then you have to do an extra query for each one. We want to avoid that, certainly. So the trick that we do is to use memo. So any workflow in Temporal has a memo, which is a key value map of sort of arbitrary user-defined data. So we can take some of that metadata, just a little bit. We don't want to include too much of it. We can take some of that, we can put it in a memo, and we can attach it to the schedule workflow. And then when we list workflows, we can pull out the memo and decode it and include that metadata in the result of the list schedules query. Let's see. So let's see. There's a few extra tricks for describe schedule. There's a cache. Those aren't too important. So okay, yeah. So I think maybe at this point, I should pause and move on, and I can talk about some of the other details, future directions, and some other stuff in Q&A later.
All right. Thank you, David. Very, very insightful presentation. We already have a lot of questions. Don't forget to answer your questions using the Q&A feature, and we will answer your questions at the end. So now I want to hand it over to Julia from Watershed, and she will share how they use schedules at Watershed and the results so far. So, Julia.
Thank you. Yeah, I'm just going to talk through our practical experience switching over to using schedules from Cron workflows. Let's get started. David, if you could help me hit next slide. Before I get into our experience using schedules, let's do some quick intros. So what is Watershed? Watershed is an enterprise climate platform, and we help companies to measure, report, and take action on their greenhouse gas emissions. Our mission is to help our customers avoid 500 million tons of carbon dioxide equivalent annually and reach net zero carbon faster, so the world hopefully doesn't burn. As for myself, I am an engineer on Watershed's infrastructure team. We're a small but mighty team of 4, and our scope includes cloud infrastructure, security, compliance, and IT. Next slide. So we've been using Temporal at Watershed pretty extensively now for over 1.5 years. And we actually just recently completed a migration off of our legacy background job running system. And so now nearly all of Watershed's async jobs are orchestrated with Temporal. This includes most of our key product functionality under the hood, like ingestion of customer data into our internal data lake, calculation of our customers' carbon footprints, sending emails to engage suppliers, and more. We have a pretty simple setup, just one namespace, a few different queues for different types of workloads, and we primarily use the TypeScript SDK. We also use the Python SDK a little bit. And we have on the order of almost 50 kinds of workloads that we run on some kind of a schedule. And that includes offline batch processing, other offline jobs like DBT transforms, garbage collection jobs to delete stale artifacts, and even integration tests against production. Next slide. David, could you help me hit next slide? Thank you. So previously we were using Temporal's cron jobs feature to run these workflows that needed to run on a schedule, but we had a number of pain points with it, mostly around UX and difficulty introspecting into what was going on with workflows. That included, it was unclear when the workflow was actually running. It would often look like it was running and doing work when actually it was just that parent scheduling workflow that was running. We needed to implement our own complex and pretty slow search logic to find past runs of a cron workflow. It was pretty tricky to update and pause existing cron jobs, tricky to manage behaviors like overlapping runs and whether it should cancel the previous run. Jitter also, we had to sort of manually add jitter by just appending extra minutes onto the end of our cron schedules. There was additional mental overhead for our developers. For example, remembering to use the workflow run ID instead of just the workflow ID to identify a cron job execution, whereas most of the time for our other workflows, they didn't have to do that. And if any of you all work on an infra team, you know that you get tons of Slack messages every day asking you why things are the way they are. And we got a lot of Slack questions about cron workflows being weird, looking weird, not making a ton of sense from a usability perspective. Next slide. So it turns out that migrating to schedules was quite easy for us, as we had already implemented a very thin declarative wrapper. David demonstrated earlier, sort of like imperatively using the CLI or the SDK client to work with schedules. For us, we just listed out all of our cron workflows and their configurations in a TypeScript file in our monorepo. And we had a step in our deploy pipeline that would apply any changes to the file just on deploy. So this actually made it quite simple for us, in addition to the fact that schedules are compatible with the cron schedule configuration. It enabled us to do a gradual and very transparent migration over to schedules as just the implementation for how these cron workflows run. And everything went quite smoothly. Next slide. So the results were the usability is definitely a lot better. In fact, pretty much no one has bothered us on Slack about how to use cron workflows, why their cron workflow is looking like it's always running, etc. ever since. And that has been really great because, yeah, I think the lack of questions really shows that that developers are able to self-serve and understand what's going on their schedules without needing help. We've also incorporated some of the new features in. We augmented our observability tooling with schedule IDs and links to the schedules UI, which is a lot easier for people to use. The screenshot here is of a Sentry error, for example, where we're able to link out to the schedule in the temporal UI. And we've also exposed some of those new configuration options, such as schedule overlap policy, and we have some schedules that are using that. All right. That was quick, but that's pretty much all I've got. So I'll hand it back to Irina.
Thank you. Thank you so much, Julia, for awesome presentation. We hope you all found this information to be valuable for you. And at this time, we are going to move into our Q&A session. So one note, if we don't answer your question today, we will reach out to anyone those questions we don't get today directly and answer a question via community Slack. So please join our community Slack. I put the link to the chat. All right, let's go and start answering the questions. David, I hope you're ready. The first question from Serdar. We experienced that UI might be confusing for schedules because they seem as running, but actually they are not. They are just scheduled. Instead of showing running, showing schedules or something could be better. So what do you think?
So just a clarification on that question. I'm not sure if if they're asking about the list, the schedules list view in the UI or the single schedule, like the schedule details page. So if I'll just answer both. So first I'll say, yeah, I think there's a few bits of low-hanging fruit for UI improvements for the web UI that we could do. And one of them, so there's another state actually that I'd like to put in there, like idle after it's finished a set of limited runs. For the list view, it may be hard. So I actually talked about this bit of implementation detail and how it's done with the memo and things. For the list view, it might actually be hard, like implementation wise, to get a reliable view of whether the job is actually running at the time or not. That's sort of an internal limitation that that we'd like to fix eventually, but there's a platform feature about notification that we're missing. So I'm not sure if that's quite possible, like if that might happen, that might be possible to do in the short term. For the detail view, like the view corresponding to describe a single schedule, I think we could do a little bit more there. Yeah.
Right. Thank you, David. So the next question is the run date or time an available input to the running job code? Thinking of the use case of specifying a date range for backfill as opposed to just the number of runs to go through.
Yes, it is. So the way that's done is we add a search attribute to each workflow that's run by a schedule. It has a search attribute that's set to the scheduled time, the time when the sort of like, if you say every hour on the hour, it'll be set to exactly the hour. Even if it started a couple seconds late, it'll be set to exactly the hour. So it's the like when the job was supposed to run. And for backfill, I sort of skipped over this in the demonstration of backfill. If you have a job, say it's scheduled every hour, you backfill a 24-hour period and you get 24 jobs. Each of them will have the original value for this, like when it was scheduled, like it'll be set to the time in the past. So from your code in the job, you can just pull out that search attribute. The exact way you do it depends on the language SDK, but it's available in all the language SDK, so it knows like when it was supposed to run.
All right. So next is, what is the recommended way with non-cron syntax to achieve more complex recurrence schedules, like every Monday, Wednesday, or Friday?
So if you I guess what's called an API, a structured calendar spec, supports basically the same features as cron syntax, but in a more readable way. So if you're doing it, so it depends on which interface you're using to create the schedule. If you're using the web UI, actually it has a nice UI that will let you literally just click Monday, Wednesday, Friday and click create, and then it just does that. And behind the scenes, it's creating one of these structured calendar specs. In code, it depends on exactly what language you're using and what the SDK looks like. They all have a way to, you basically just create a struct, and then you have a list of ranges, and then for the list of ranges, you'd say Monday, Wednesday, Friday. For day of week, you'd put an hour, a minute, when you want it to run, and for the CLI, you do a similar thing in JSON.
Awesome. We also had a question about public documentations for schedules, and I put a link to the chat. All right, next question. Is there a limit to how often you can run cron jobs? I'm assuming the same as cron, like 1 minute, but not sure if you allow for more frequency executions.
What the base that we aimed for with schedules is accuracy of a second. So you can actually create a schedule that runs once a second, no more than that. That's yeah, you can do that. Whether it makes sense to have a workflow running every second, if the workflow really completes that quickly, maybe it does. But yeah, we do allow for once a second.
Awesome. Next question is, could you elaborate a bit on a workflow run can access the result of a previous run?
The exact way you do it, again, depends on the language SDK. In Go, you would, I primarily work in Go, so I'm most familiar with Go, so I'll say that one. In Go, it looks like, workflow.getInfo, and then last completion result. You can access, so search in the docs for like last completion result or last result. It's the same. It's the same thing that you would do with the old temporal cron feature. There's two things available to you: last completion result and last failure. If the previous run failed, you can get the failure details from the last run to see how it failed. And then you can get the result of the last successful run. The same API methods work on the old temporal cron and also with schedules.
Perfect. Thank you, David. The next one is there a Terraform model for specifying scheduled jobs?
There is not yet. I would like there to be. That's something that we've been talking about internally for a while. Terraform for schedules, for namespaces, for other aspects of temporal configuration. It's on, I'd say it's on the roadmap, but there's no, I don't have any specific ETA right now. That also sounds like something that could be a great third-party contribution. I think we'd be happy if someone just if someone did that and contributed it or maintained it as a third-party library or something, or maybe a base for more Terraform-based temporal things in the future. Besides Terraform, I'll also mention, this is one of the slides I was going to get to later. Besides Terraform, which is a sort of infrastructure as code where you can define things in they typically be in your Terraform files in a Git repo or something. There's also a use case where you want to synchronize a set of schedules, not from like something written in code, but from a set of business entities in a database or something like that. That's also something that we have been thinking about, and they're similar, but they're maybe a little bit different. In both cases, you're synchronizing the state of schedules in a temporal cluster with with some source of data, whether it's like Terraform code and Git. It's definitely stuff we're thinking about, and hopefully there'll be some action, something to talk about there soon.
Perfect. So what's a good practice for deploying new schedules to prod? Should I delete all existing schedules and create new ones?
Yeah, so that sort of ties into the previous question also. Ideally, so I guess it depends where exactly your schedule configuration is coming from. Ideally, yeah, if you're already using something like Terraform, that would be great if it existed. Terraform provider doesn't exist right now. So what I would suggest is first, I would say do not blindly delete and recreate schedules because you'll lose a bit of state there. So, for example, controlling, like buffering runs or controlling the overlap policy, there's per schedule state in there. So if you delete them and recreate them, you lose some of that state. You could end up with multiple runs running at the same time, which you didn't intend. Instead, you can describe the schedule, see if it exists and get the current state. If it does not exist, create it. So this is a bit of code to write that's like, I guess, Julia talked about how her team created code like this that would sort of synchronize a set of schedules. So unfortunately, we don't have like I guess we have some sample code for this, but we don't have a library we can point to and say, just use this right now. But it's not that hard to write for most use cases. You would want to, maybe list or describe the schedule. If it exists, then you can do an update to change the configuration. If it doesn't exist, you can create it, and then pretty much that.
Okay, next question is self-hosted Temporal. And yes, don't forget that Temporal is 100% open source. The question is, we are using self-hosted Temporal with schedules. Are there internal worker limits that would affect schedules running on time? We have some schedules that appear never to run and only ever see them log schedules missed catch-up window. It does not seem like our cluster has outage at this time, but trying to identify why this happens.
So I would suggest, first of all, if you're seeing specific problems, maybe post something in the community Slack, and I or someone else can help you debug. Just to give a few brief pointers that might help, we changed the catch-up window controls how late a run can be. So if it's scheduled for 10 o'clock exactly on the hour, but the temporal system is bogged down or something and doesn't actually get to it until say 2 minutes later, if your catch-up window is only 1 minute, then it'll say, oh, it's too late, it won't run. So if you we changed the default, so the default catch-up window now is 1 year, effectively infinite, right? So we always try to run things even if they didn't run at the right time. If you explicitly set a shorter catch-up window for your app because it makes sense for your application, that's fine. If we did change the default at one point and it was 1 minute, which maybe is not the best default, so we changed it. Okay, so worker scaling. So if you do have a large number of schedules, there are some settings that you should tune on the internal server worker. I can't maybe get into all the details right now, but there's a few settings where you can increase the number of pollers and the number of workers per namespace, and that'll provide more capacity to running schedules. You shouldn't have to do this unless your like overall load is more than a few jobs per second across all namespaces, let's say. So if it's not that great, there may be something else going on. But for higher load, yeah, there's definitely some tuning that can be done. It's similar to worker tuning for temporal applications, but it's for the internal server worker instead. So yeah, so I can give a few tips in Slack maybe.
Mm-hmm. All right, we will answer 2 more questions, and the rest questions we will post on our community Slack in the support channel, and we will answer all of them there. So join our community Slack and read the answer to your questions. So the question is, can we limit the number of runs for a scheduled action?
Yes. Yeah, that's one of the features that I mentioned. You can say something like run 5 times or 100 times and no more. And then after it runs that many jobs, it will the schedule will exist, but we'll call it idle. And it'll automatically get deleted after a week unless there's another run or unless you do a trigger, for example, or update it. Yeah, so you can set a fixed limit. You can also set an end time. So you can say run on this schedule until the end of 2023 and then don't run anymore.
Yeah. Okay, and the last question. Okay, let me choose. Let's do this one. We are currently evaluating temporal, and Cron would be helpful, but we also have scheduled future runs that are expected to run once at a specific time. How would we implement this in temporal using schedules or another setup?
Yeah, this question comes up a bunch on Slack and other forums. So you can do it by each time you want to run something once at a particular time. Yes, so there's this limited number of actions features. So you can create a schedule and you can say run at this time and run once, and then it'll do exactly that. So that works. The concern, so we usually don't recommend that, and the reason is because of this implementation, so some of the implementation details that I talked about, where a schedule is a separate workflow. So if you have just a few of those things, that's fine. You do it and don't worry about it. If you have many of those things, so that if the throughput of those things is like, I don't know, tens or hundreds a second or something like that, the extra workflows created by schedules are well, they're just extra workflows. They'll they have to do the same transactional stuff as other workflows in temporal, so it will it's not the most efficient way to do it. For actions that you want to happen exactly once at a particular time, the most scalable way that we often recommend is start a workflow. So just do for that thing, start a workflow, pass in the desired time in maybe part of the workflow input, and then in that workflow, the first thing that you can do is just sleep. Figure out when you want the thing to happen, and then just sleep until that time, and then wake up and then run the rest of the workflow. That's about as as accurate as whatever schedules would do, because they're using the same timers and things. But there's only one workflow there, and it's just doing a sleep. So it'll be more efficient. If you're using Temporal Cloud, it'll cost a bit less as well. Yeah.
Awesome. Thank you so much, David. That was the last question. And as I said before, we will publish all other questions on our community Slack and the support channel, and we will answer all of them. So please find your question there. And that's it for today. I want to thank our speakers, Julia and David, for very insightful, interesting presentations. I want to thank all of you to attend our webinar. Please join our community Slack, follow Temporal and Watershed on LinkedIn, and have a good rest of your day. Thank you.